A torque converter is a type of fluid coupling which is used to transfer rotating power from the engine of a vehicle to the transmission. It takes place of mechanical clutch in an automatic transmission. The main function of it is to allow the load to be isolated from the main power source. It sits in between the engine and transmission. It has the same function as the clutch in manual transmission. As the clutch separates the engine from the load when it stops, in the same way it also isolates the engine from load and keep engine running when vehicle stops. Its main functions are: 1. It transfers the power from engine to the transmission input shaft. 2. It drives the front pump of the transmission. 3. It isolates the engine from the load when the vehicle is stationary. 4. It multiplies the torque of the engine and transmits it to the transmission. It almost doubles the output torque. Working principle. For understanding the working principle of torque converter, let's take two fans. One fan is connected to the power source and other is not connected with power source. When first fan connected to the power source starts moving, the air from it flows to the second fan which is stationary. The air from the first fan strikes on the blades of the second fan and it also starts rotating almost at the same speed to the first one. When the second fan is stopped, it does not stop the first one. The first fan keeps rotating. On the same principle the torque converter works. In that the impeller or pump acts as first fan which is connected to the engine and turbine act as the second fan which is connected to the transmission system. When the engine runs, it rotates the impeller and due to the centrifugal force the oil inside the torque converter assembly directed towards the turbine. As it hits turbine blades, the turbine starts rotating. This makes the transmission system rotate and the wheels of the vehicle moves. When engine stops, the turbine also stops rotating but the impeller connected the engine keeps moving and this prevent the killing of engine. Main parts. The torque converter has three main parts. 1. Impeller or pump. The impeller is connected to the housing and the housing connected to the engine shaft. It has curved and angled vanes. It rotates with the engine speed and consists of automatic transmission fluid. When it rotates with the engine, the centrifugal force makes the fluid move outward. The blades of the impeller are designed in such a way that it directs the fluid towards the turbine blades. It acts as centrifugal pump which sucks the fluid from the automatic transmission and delivers it to the turbine. 2. Stator. The stator is located in between the impeller and turbine. The main function of the stator is to give direction to the returning fluid from the turbine, so that the fluid enters to the impeller in the direction of its rotation. As the fluid enters in the direction of the impeller, it multiplies the torque. So stator helps in the torque multiplication by changing the direction of the fluid and allows it to enter in the direction of the impeller rotation. The stator changes the direction of fluid almost up to 90 degrees. The stator is mounted with a one-way clutch that allows rotating it in one direction and preventing its rotation in other direction. Turbine is connected to the transmission system of the vehicle. And the stator is placed in between the impeller and turbine. 3. Turbine. Turbine is connected to the input shaft of the automatic transmission. It is present at the engine side. It also consists of curved and angled blades. The blades of the turbine are designed in such a way that it can change the direction of the fluid completely that strikes on its blades. It is the change in the direction of the fluid that forces the blades to move in the direction of the impeller. As the turbine rotates, the input shaft of the transmission also rotates and made the vehicle to move. The turbine also has a lock-up clutch at its back. The lock-up clutch comes into play when the torque converter achieves coupling point. The lock-up eliminates the losses and improves the efficiency of the converter. Working of torque converter. It has three stages of operations. 1. Stall. During stall, stop, condition of the vehicle, the engine is applying power to the impeller but the turbine cannot rotate. This happens when the vehicle is stationary and driver has kept his foot on the brake pedal to prevent it from moving. During this condition, maximum multiplication of torque takes place. As the driver removes its foot from the brake pedal and presses the accelerator pedal, the impeller starts moving faster, and this sets the turbine to move. At this situation, there is a larger difference between the pump and turbine speed. The impeller speed is much greater than the turbine speed. 2. Acceleration. During acceleration, the turbine speed keeps on increasing, but still there is large difference between the impeller and turbine speed. As the speed of the turbine increases, the torque multiplication reduces. During acceleration of the vehicle, the torque multiplication is less than that is achieved during stall condition. 3. Coupling. It is a situation when the turbine achieved approximately 90% speed of the impeller, and this point is called coupling point. The torque multiplication ceases and becomes zero, and the torque converter behaves just like a simple fluid coupling. At the coupling point, the lock-up clutch comes into play and locks the turbine to the impeller of the converter. This puts the turbine and impeller to move with the same speed. Lock-up clutch engages only when coupling point is achieved. During coupling, the stator also starts to rotate in the direction of the impeller and turbine rotation. Note 1. The maximum torque multiplication takes place during stalling condition. 2. The stator remains stationary before coupling point and helps in the torque multiplication. As the coupling attained, stator stops torque multiplication and starts rotating with the impeller and turbine. 3. Lock-up clutch engages when coupling point is achieved and removes the power losses, resulting in increased efficiency. Advantages. It produces the maximum torque as compared with the vehicle equipped with clutch. It removes the clutch pedal. It makes the job of driving a vehicle easier. Disadvantages. Its fuel efficiency is low as compared with the vehicle with manual transmission. If you liked this information, then don't forget to like, subscribe, and share.